Dragon, SpaceX, go for launch.
SpaceX Dragon, we're go for launch. Let's light this candle.
T-minus 30 seconds.
Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff of the Falcon 9 and Crew Dragon. Go NASA, go SpaceX, Godspeed, Bob and Doug.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Amal Lukman. Me and my friend represent Composite in Aerospace in course code PST252. So we start the first one. So we go to the first one. The history for composite materials in aerospace. Glass fibers was embedded in the resin matrix in the 1950s for designing Boeing 707 passenger jet. In 1960s, composite plates of the RB211 jet engine developed by Rolls-Royce made of by carbon fiber. Fibrous composite materials were originally used in small amounts in military aircraft in the 1960s and in civil aviation from the 1970s. Since 1980s, composites have primarily been used for the secondary wing and tail components. Each generation of new aircraft developed by Boeing has had an increased percentage of composite materials, with the highest being 50% in Boeing 787 Dreamliner. Aramid fibers are widely used for the constructing leading and trailing edge wing component. It is very stiff, very light bulkhead, full tanks and floors. Advanced composite consisting of a combination of high-strength stiff fibers embedded in a common matrix material are also widely being used in the aerospace industry. Evolution of aerospace structural materials. Early aircraft design used a type of composite such as wood, canvas, and high-tension wires with flight control achieved by twisting the tips of the wings. Carbon fiber and glass fiber reinforced polymers first included in aircraft during the 1970s. The aerospace industry, however, inherently conservative, resulting in a small step-by-step approach. Composite have taken a long time to really take off. Conservatism is designed as also a limited platform shape and construction to that of proven metallic design rather than embracing and designing for new materials. As you can see, composite structure weight development figure, the composite structure weight in percentage has increased years by years from 1970 until the 2010.
Hi, my name is Shanta. Next, I'm going to present about definition of composite material. Composite material is a material that makes from two or more constituent materials with significantly different physical or chemical properties that, when combined, produce a material with characteristics different from the individual components. Definition of polymer composite. PMC is a composite material composed of a variety of short or continuous fibers bound together by an organic polymer matrix. PMC are designed to transfer loads between fibers of a matrix. Some of the advantages with PMC include their lightweight, high stiffness, and their high strength along the direction of their reinforcement. Other advantages are good abrasion resistance and good corrosion resistance. Next, I want to explain about the application of composite in aerospace. The application is as a wing flaps, rudder, elevators, radio, helicopter main and rotor blades, and space of vehicles.
My name is Hazman Haziman, and I would talk about material use and example composite in aerospace. First one is horizontal and vertical stabilizer. The horizontal stabilizer prevents up and down or pitching motion of the aircraft nose, and for vertical stabilizer are intended to reduce aerodynamic side slip and provide direction stability. The second one, radome. Radome is a structural weatherproof enclosure that protects a radar antenna. It also protects nearby personnel from being accidentally struck by quickly rotating antenna. And the third one is aircraft fairing. Aircraft fairing is a structure whose primary function is to produce a smooth outline and reduce drag. The structure are covered for gaps and space between parts of an aircraft to reduce form, drag, and interference drag and to improve appearance. And the fourth one is wing box. The wing box of an airplane is a structural component from which the wings extend. It is usually limited to the section of the fuselage between the wing root. Although on some aircraft design, it may be considered to extend further. Engine cooling. Engine cooling reduce parasite. The last one is engine cooling. Engine cooling reduce parasitic drag by reducing the surface area, which prevent a leaf flow separation. The inlet and the nozzle in combination lead to an isotropic speed reduction around the cooling fin and due to the speed square law to a reduction in the cooling drag.
We will go through on the slide of advantages and disadvantages of composite in aerospace. The first point in advantage is weight reduction. Weight reduction savings in the range of 20% to 50%. This is the greatest advantage of composite in material usage. A lower weight plane is more fuel efficient because it requires less fuel to propel itself forward. So the more lower weight plane give the better fuel efficient. Okay, next is strong and have a higher strength to weight ratio, also known as specific strength. Here we can see it is related between the stronger of the composite and the specific strength. The more stronger of the composite gives the highest specific strength. Okay, next are not prone to corrosion due to harsh chemical, and they are resistant to many highly reactive chemicals. Last point is design flexibility. Design flexibility, they can be made many type of shape. The oddly shape can be replaced or can be used to other material. Hence, it will lower the cost and will cut down on maintenance. Next, we go through on the next slide disadvantages. The first point is higher initial cost compared with metals. The greater cost is due to the price of the fibers and the process in making of this material. This process is very difficult and very complicated to make the finished material. That's why the cost is higher. Okay, next, repair will introduce new problem, such as hot curing is necessary in many cases, requiring many equipment. Next, repairing at the original cure temperature requires tooling and pressure. The last point in disadvantages of composite in aerospace is composite are more brittle than rough metal, and it will easily damage.
Hi, I'm Aisha. Next, I will explain about types of composite. Number 1 is fiberglass. Fiberglass is made of tiny glass shards held together by resin and other components. It commonly used for body kit. It is waterproof, lightweight, and strong, also inexpensive. Number 2 is concrete and reinforced concrete. Concrete is a composite material made of cement, sand, stones, and water. The chemical reaction makes the concrete much stronger. It is commonly used for building and road construction. Number 3 is nature composite. This composite can be found in nature, such as wood. It is because cellulose fibers are held together by a substance called as lining. The bonding power of lining in wood that make it much tougher. And then for aerospace structure and feature. First is fuselage. Fuselage is to carry load. The shape is different for different aircraft. For example, for transport aircraft, the shape is cylindrical or near cylindrical. And then number 2 is wings. It is to provide lift. They have two parts of wings, which is internal wings and external wings. For internal wings, they have ribs. The shape for ribs is aerodynamic shape. And then they have spars and stringers. For the tail, it is to provide the stability and control because aircraft flies in 3 dimensions, which is the first dimension is left and right, and then for the second dimension is up and down, and then the third dimension is forward and backward. For undercarriage, it is to provide smooth landing. Also, it is used for shock absorber during landing. It must be small and lightweight. For the engines, it generates mechanical power. It is preferred use titanium alloys due to high specific strength and wide temperature range. This is our reference. Thanks for watching. Assalamualaikum. Selamat Hari Raya Maaf Zahir dan Batin.